In this video, I will be looking into creating objects. I will be making flippers, ball guides, these solid prisms I will be calling plates, and rubber barriers. Whether or not I will be doing it correctly will be determined in the future. If it works for me, I won't complain. But a quick catch up between the last video to now. The previously big overlay will now be made smaller and made collapsible so I can hide it. It will only be visible as debugging info for now, and more might be added to it later. Also, I have been fiddling with the physics settings, so not everything is entirely how I want it yet. The ball is set up to have the bounciest physics material, while the other surfaces that it might collide into have a flag absorbent set to true. The reason why is that the metal balls should be able to bounce between each other while reaching a stable rolling state on the table and curved surfaces. I also gave it a checkered texture because the spin of the ball is important to know. Alright, let's get these flippers added, before I go crazy only having to move the balls around with my mouse. Flippers are the main component of the game that will control the ball's movement. They are usually placed near the player's point of view near the bottom of the screen, sometimes in the side of a loop or its own mini playfield. They almost look capsule-shaped, where the pivot it rotates on is at its thickest and tapers down a bit to its tip end. Now I could model these flippers and let the engine automatically generate the physics collider shape from the mesh. However, I can see in the future where I want many different lengths and thickness. So I am going to jump right in trying to procedurally generate these things. A flipper's general shape can be defined from a loop around its perimeter. It uses arcs of two circles whose centers are set at a distance from each other, and lines tangent to those arcs to connect their ends between them. I use necessary pairs of points to make the straight edges and extra smoothing points on the arc portion along this loop. Along with these points, each will have to store the outwards normal vector of the curve. This will be necessary for giving the flippers a more recognizable appearance. Using this information, the vertices can be created on and above the points at a specified height to make a simple irregular prism. The sides of this mesh is smoothed out thanks to the normal vector stored before. The top and bottom faces uses Godot's triangulate polygon helper function from the Geometry 2D class to cover it, while the sides uses triangle strip method of generating the mesh. It seems the flipper is a bit sharp at these edges. I will give him a bevel to make it look smoother by using more triangle strips. It is also missing a rubber that usually goes around these flippers. Instead of artificially adding more thickness to the base shape, I will cut into it to help preserve the overall dimensions. This is again helped with the normal vector store before, but instead of the outwards direction, it goes the other way. And finally, giving the rubber its own height centered on the height of the internal base shape. Now that we have a visually recognizable flipper, it is time to add the physics collision shape. Two cylinders at the base and tip using the same radius values, and two boxes that make up the tapered edges that follow against the length of the tangent line between the two circles. I'm converting it to a rigid body object and attaching it to a player-controlled motorized hinge. The hinge will have rotation limits and will freeze or turn to static when it reaches those limits. Sometimes the flipper gets stuck during a flip. This is usually the case where the flipper gets stuck on the table surface the ball needs to roll on. So I'll quickly modify the collision layers it uses to not include the table surface. Now let's test it out. I've made a test area here with the flipper and a ball on a flat surface. Here I set up a script to randomly spawn the ball along the flipper and flip immediately. There is an issue with the way I set up the collision shapes for the flipper. Normally the ball goes in a direction determined where it's positioned along the length of the flipper. Here with the typical left flipper where the ball starts from a standstill, near its base it would go a little behind or left of the flipper. Around the center would send the ball generally up, and flipping late as possible near the tip would send the ball in front or right of the flipper. But for some reason, when the ball is placed just right between the center and the tip, it gets launched as if it was near the base, leftwards. I have a theory where the ball is processing collisions separately from the box and cylinder at the tip, and when it comes to calculating the cylinder collision as it flips, it pulls it back because of the angled surface of the cylinder at the tip, instead of prioritizing the more closer, flatter surface. So for the middle and the tip, I will use a convex hull shape. I get better results for that area. Alright, so what makes up the shape of a table? Well, a lot of things. let me rephrase that question. What makes up the shape of the playfield? The playfield is where the ball will actually go around on and get to interact with other components. There are parts of the table that the ball will never get to roll on, and usually additional artwork, some plastic, or theming gets to show off there that would cover the void space of the pinball table. Between both spaces are divided by walls known as ball guides, maybe some sheets of material leveled at the center of the ball, or some rubber barrier. Making a typical metal strip guide is quite easy. They can take a path, in this case a Bezier spline, by sampling points along it and keep track of the normal that would point laterally along the path. By having points get created directly on the path and flat grounded ones, or at least zero elevation in the node space, I could create a variable height ball guide mesh through these points. After that, make more pairs of vertices out of the points using normal direction before to separate them and connect them up with the triangle strips. Typically, they should at least be higher than the ball, but I can see potential use for having different heights. The wire variant of ball guides are also easy, although funky math is used to get the ends to bend down and terminate nicely. Again, I use the path and sample the points, but this time I will make the points keep track of the direction it's going by getting the tangent of the path. To get the wire to end into the ground, additional points at each end of the path is added. I get the angled direction and use it as a starting point of an arc on a circle. Go around the circle until it's pointing straight down, and then add one final point on the ground. These points using tangents will orient the rings of the vertices I will be placing at each. From there, a pipe will be formed through these rings. We get a wire ball guide to also place around. The heights of these are slightly above the radius, or half the ball's height, but again, the potential for varying heights is also there. And finally, these most primitive looking shapes, which also look like irregular prisms. They can be used as solid barriers, thin sheets to act as if ball guides, or decorative covers. They use the same method as generating a flipper, where the loop is a path that connects into itself, but instead of a calculated loop, it uses a closed loop spline. Making them all collidable with the ball is as easy as using a method from the mesh class, create try mesh shape, to turn any mesh into a physics shape and putting it into a static body. Additionally, I have added parallel lines in the editor that are placed out at diameter's length of the ball, so I know how to space these to not accidentally wedge the ball. Procedurally generating the rubber barriers combines concepts of what was mentioned previously. I need a loop path to be generated that goes around the posts that are placed on the table. I will be using these post models I made in Blender that will visually hold up the rubber. These posts will have the data attached to them, which are the height and radius the rubber ring would wrap around on. All of them will be placed in the scene as a child under the node containing the barrier generating script. This script will use its children to generate the appropriate rubber shape. Find the tangent line between each pair of circles of posts. Create necessary endpoints for each straight tangent and additional ones for the wrapping curvature around each post. Expand each point to a ring that faces along the path's tangent, and then have a pipe go through those rings. Using the same loop shape, an optional plate cover can be made over the entire barrier. To create the collision shapes that will encompass this mesh, I will borrow the first method of generating the flippers, where the cylinders will be placed at the posts that have the combined radius of the post and the wrapped rubber, and the boxes are aligned to each stretch of rubber between pairs of posts and are long enough to meet the centers of those posts. I believe the issue I encountered with the flippers using this method will not happen on here, as I think that is something that occurs with the rigid body and not a static one, or that the effect of it is less. Now I should have enough parts to build a bare table layout. I'll attempt to make a table with what I got so far using this rough sketch I drew out. Finally, a pinball table of sorts. It's pretty bare looking since there is no interactable components and decorations placed around. And as you can see, I still have to manually launch the ball with a magnet. But at least it's playable to a degree with the typical controls. Plungers or any form of initial launch of ball is probably not that hard, but I was not focusing on it for this video. I would say that the rubber barriers were sort of extra. I could have just went with the previous plates and made their physics material bouncy, but the barriers are so prominent in all tables that probably not seeing one is strange, and having the ball bounce off a visibly solid surface will not feel right. This video took way long to make, but also felt as if I was rushing it as well. I made special presentation scripts within the game engine to record to minimize the eventual work of video editing. Hopefully they will help for the next video in a way. However, a majority of the required procedural stuff have been covered, so it will likely take less advantage of the scripts. I'm thinking about making the next videos shorter, about 1 or 2 major things being implemented, but the total amount of things in a video may not adhere to that limit. If they are simple, then they probably won't take up those major slots and will be added to the next video as well. I don't know. I'm very conflicted with how I want to do the next one without tiring myself out. I want to progress on my project, but these videos are also very important to me. If there are any questions about what was explained, suggestions on how to execute the video, or would like to see implemented next, please leave a comment on this video. Otherwise, I hope you like what you watched. See you next time.